So the last step in wrapping up our college prep option D systems of equations is taking our new strategy of elimination and now applying it to the real world to give advice just like last week when we finished up our substitution. So we will go and make sure you know where our final workbook is. So when you're at the Math with Baki classroom, go over to classwork. You will see that I posted a option D final workbook to click into. And this will be the applications that you guys will work through to end up the week today and tomorrow. The first slide is just the exemplar, where you still need to make sure you have that nice graph with a picture of your awesome algebra right next to it, and then your advice that explains what you got for X and Y in context of the problem. So we're going to do this first one together so you guys understand and sort of remember what to do. Then you guys will do these other two on your own. And just as a reminder, if you click on Graph with Solution on each problem, I went ahead and made sure that the window in Desmos exactly matches the size of the numbers in the problem. So when you graph, you'll always see your solutions if you click and use those Desmos graphs. So let's do this first one together. You're asked by your boss to figure out the most cost-effective plan for producing a standard drill and a cordless drill. The standard model takes 2 hours of labor to assemble, while the cordless model takes 3. There are 72 hours of total labor available with the number of employees you have in 1 week, and material costs for the standard drill are $10, and cordless drill has material costs of $20. Your boss does not want to spend more than $420 per week making those drills, so we want to try to figure out how many standard drills and cordless drills they should make to use all 72 hours of labor and all $420 of costs. So I'm going to click on my Desmos here so it automatically has the window. And right here we see 2x is going to stand for the 2 hours of labor for the standard model. 3y goes with the 3 hours of the cordless model. And when we add those together, they should equal 72 hours. And then $10 for the standard drill is what 10x represents. It costs $20 to make the cordless drill, so we put 20y. And when we add those together, we want those to equal 420. Haha. So we're going to go type in our two equations to go ahead and get the solution. So we already have the answer right next to it when we solve with elimination. So 2x plus 3y equals 72. And 10x plus 20y equals 420. And voila, we have our intersection. So now you guys can take a nice screenshot to go put in there. Your guys' process looks a little bit different than mine, being on a Chromebook. But then voila, you guys should have the nice looking graph. So we already know when you go and solve this with our new strategy of elimination, we know that x should be 18 and y should be 12. I'm going to let you guys solve this. You guys can review yesterday's Nearpod if you need some more help using these two equations and stacking them on top of each other for elimination. But I'm going to go ahead and make sure we know how to use the cheat sheet, that advice to answer how many of each of these we should make. Because we already have our answers. We know x is 18. We know y is 12. And if we go back up here, we know that 2 went with x. And 2 was talking about the standard model. 10 went with x. $10 was also talking about the standard model. So x right here represents that we should make 18 standard drills, and y will be 12 standard drills. So if we move this over, we once again have a nice sentence stem that you guys can copy and paste on your advice box. So now you guys should be able to more easily type in your answers. So in order to use all 72 hours of labor and to only spend $420 per week, we should make 18 standard drills and 12 cordless drills. And of course, you guys will need to make sure you have your algebra that matches x equals 18, y equals 12, and then you guys are good to go. And you just have 2 more applications to do on your own. And just a reminder, you guys can always click on that graph with solution to make sure that the Desmos graphing window will work perfectly for your graph. So you can see that intersection of solutions.